don't remember what it was. Erica, are you with us? I thought you had.
Yes, I'm sorry.
No?
I'm going to look it up.
Yeah, no worries.
But I don't have my textbook up right now.
Oh, okay, so you said it was from 5.7?
Yes.
Okay, and the problem?
Number 10.
Number 10. Okay, I have it. So we have y equals x natural log x plus 3x minus 2. And is it a solution or not of this equation? Is that the one?
Yep, that's the one.
Okay, perfect. So in order to build this, I have to find the second derivative of y. But I can't before I find the first derivative. Can anyone help with the first derivative, please? Anything. Anything that you can help with.
ln of x plus y plus 3.
Yes. So the first function prime is 1 times ln x plus the first function times the second function prime. So this is the product rule. So what is the derivative of natural log x?
1 over x.
Thank you. Plus the derivative of 3x is indeed 3. But here we simplify, and this becomes 1. So this is natural log x plus 4. So this is the first derivative. Now we have to move on to the second derivative. Can anyone give us the second derivative of this function? I mean the first derivative of this function, but the second derivative of the original function.
Is just 1 over x, right?
Good. Excellent. So when I plug this in, it turns out that 1 over x minus 1 over x is indeed 0. And I go back and I say yes. Very good. Other questions? Is this okay? Is this clear?
Yes, it is. Thank you.
Perfect. Anything else you need help with? Anything? Anything from the written homework, from Pearson, anything?
I just have a quick question for you.
Yes, I'm ready.
How would you prefer us to say if the solution is true? Because, like, for example, on my homework, I just finished with that last equation, 1 over x minus 1 over x equals 0, and I put a check mark next to it. Is that fine?
Perfect.
Sounds good, thank you.
Good. Anything else? Other questions for me? Okay, in that case, let's go back to chapter 6. Chapter 6 deals with functions of multiple variables. In other words, we are no longer talking about f of x. We're done with that for now. But we're talking about f of x and y, or f of x, y, and w, or f of a, b, or f of a, b, c, d, and so on and so forth. So this is something called multivariable calculus. We're only going to get a little taste of it, not a lot. Okay. So as I promised, we start with the easiest section of this chapter, only because it only has algebra in it. Not even calculator, to be exact. Calculator. Okay, so what happens is we have a scatter plot that looks kind of linear, and we are trying to fit a line through it that is called the best fit. So what does this have to do with calculus? Because the line of best fit has a minimum error. Whenever we use the words min or max, we immediately think of calculus. So that's what it is. We're not going to look at the mechanism behind how this line is determined. We're going to go directly and use the calculator. But the reason 6.4 is in calculus, it's because of this key word. Every time we talk about min or max, we talk about derivatives. When we talk about derivatives, we talked about calculus. That's the only reason. Okay, so let's go directly to a problem. So where are you guys? You're here. I see you. Okay, good. So let's take a look at, I don't know, let's say football ticket prices. So they're giving us the cloud or the scatter plot. So I'm going to copy the information in the table. So X is the number of years since 2012. So 2012 means X equals 0. I will copy the table so we have it here. And the average ticket price in dollars. And we only have 5 points. So 0, 1, 2, 3, and 4, and the corresponding price is 78.38, 81.54, 84.43, 85.43, and 92.98. Now, I am going to put this information in the calculator. I'm going to go directly to the calculator, and I am going to record this. Record. I want to record on this computer. Yes. Okay. So the first thing we do, we go to stats, and we want to edit. And I want to edit 2 lists. And do not change anything in the order. So clear. Highlight the top of the name of the list, clear, enter. Everything is gone. In list L1, I only have 0, 1, 2, 3, and 4. These are the number of years since 2012. And in the Y column, I have 78.38, 81.54, 84.43, 85.43, and finally 92.98. Good. I would like to see the scatter plot. Okay. I go to second and quit. I go to second and stat plot. I will choose number 1. I will turn it on. I will choose the first item. All these are something else. This is the scatter plot, the type of the plot I want. I want the scatter plot. I want the X list, yes, to be list L1. I want the Y list, yes, to be list L2, correct. You can choose any mark you want. You can choose any color you want among the ones that are offered. And then I will click on Zoom Stat. What does that do? It will give us the horizontal axis that we need for the data set we have, and the vertical axis, the y-axis that we need for the data we have. We don't have to adjust the viewing window. So Zoom 9 is Zoom Stat. I press on 9 and I see the cloud. I prefer adjusting the window myself because I don't want the calculator to give me so many ticks vertically and very few horizontally, but it works. It's fine. So this is what I see, and I kind of, right, it looks like linear. It doesn't look like quadratic. It doesn't look like exponential or logarithmic or something. looks linear. Okay, then I would go back to, get out of there, and go back to stats, and this time I want to do calculations. So I move over to one item, and I look for what I'm interested in. Here it is, linear regression. It would be a line, which is mx plus b. Why they chose to use a, I don't know, but this is the slope. Slope times x plus b. So I'm going to choose number 4. List L1 again, yes. List L2 is for y values, yes. Frequency, I don't care. But it says, do you want to store the regression line in your calculator? Yes, of course. I don't want to type it in myself, not because I'm lazy, but because it will use all the decimal digits it comes up with. So here's how I do that. Press on variables, go to the y variable. It is a function. I choose y1, press enter. So now, the linear regression, the calculator will calculate the linear regression line, which will give us the slope, mx plus b. Furthermore, it will store the equation in y equals under y1. Finally, I want to calculate, and I press enter. Here it is. The slope is 3.309, so then y equals 3.309 times x plus b, which is the y-intercept, 77.934. This was nice. It was not, it did not have the infinitely many decimal digits. It was quite nice. So now here's what happens. Let's look at y equals. It's right here. It's already in there. Now when I press graph, I will see the scatter plot that I saw before, including this line. Very convenient. Boom. That's it. So the calculator, by saving the line in y1, and I did not have to type it in myself, and when I clicked on graph, it showed both the scatter plot and the line of best fit. So I'm going to, maybe not yet. So the second part of the problem, it says use the regression line to predict the average ticket price for the NFL game in 2020 and 2025. So for 2020 and 2025, I have to determine which year that is. So this was in 2012. This is 2012, 13, 14, 15, 16. I have to caution you because the range of the data here from 2012 to 12-16 may not be good enough to predict so far out in the future. We will do it, but we have to be skeptical of the results because we don't know if the trend continues beyond 2016. If somebody can tell me, yes, the trend will always be this, then I will have no problem plugging in the exact number of years since 2012 for 2020 and for 2025. But no one knows that this model continues to be valid. So what is X for 2020? Can anyone help? And what is X for 2025? So X for 2020 is? Is anyone with me?
8.
Yes. And for the other one?
13.
Yes. All I need to do is go back to the calculator, go back to with the second and table, and plug in 8 and 13. If you want to keep whatever you have in there or fine, but I don't care, and I just need the numbers. So here is the outcome, and please, I saw it in your notes, in your solutions for homework. Please, if we are talking about dollars, please use 2 decimal digits. So the first one is 104.41, in dollars, of course, and the second one is 120.95. Let me stop stop recording. Okay. This is it. That's all we're asked to do in this section. Now you can say, why did you use this hat? Because this is really the correct notation for the predicted values. So this is the regression line, and these are the predicted values of y for x equals 8 and 13 respectively through the regression line. Will they be exact? No. Unlikely. But close. Will they be close? I don't know. Because this is kind of far out from the data. If somebody says this trend will continue, then these will be close. Any questions about 6.4? That's all you're asked to do. Just put the information in the table, in the calculator. Hopefully you will save the regression line so you don't have to plug it in yourself and maybe make an error. And you are asked to predict. I am comfortable to predict within the range of x. I'm not really comfortable to predict outside or too far outside, because these may not mean anything. That's it about 6.4. Anyone, any questions? Any questions? Anyone? Is this good enough for the linear regression analysis?
Yes.
Thank you. Okay, so now we can go back to 6.1 through 6.3. In 6.1, we're going to look at functions of several variables. Only two very, very simple things: domain and how to evaluate. That's all about 6.1. Nothing new. Let me